Hey guys, we are going to talk about transforming absolute value equations today. We talked about this yesterday, and we've talked about the transformations before. So our goals for today are to transform absolute value equations, or functions rather, and then to write the equation of an absolute value function given the graph, or a description of it. So first, some terminology. The vertex is our turning point. That's another word for it. So it's like the tip of the V. So this right here, this point here, that's called your vertex. Okay? Sorry, it's making sure our volume is plugged in so I don't have to make this video twice. Okay, so it says to graph the original function f of x and then graph the transformed function defined by g of x and write the equation of g of x in terms of x. So we already did this when we did linear functions and linear transformations. So yesterday you learned about the parent function, which would be the absolute value of x. So now they're just making your parent function a little bit more complicated. So this is my starting function, and then I'm going to transform it, okay, according to the rule that's written here. So based on this 4 being inside, that would mean that this would move left 4, because that's what the plus 4 inside means. So the first thing I do is I graph the original. So x plus 2, absolute value of x plus 2. So now absolute value of x would be here at the origin, slope of 1 on each side. So the plus 2 is going to move me left 2. So here and then here. So I graph the original. And that is my f of x. Then I want to take that and I want to go left 4 according to that transformation. So I take the vertex 1, 2, 3, 4. So you have to have those transformation rules memorized. If you don't have them memorized, you might want to write them out on an index card until you do. Otherwise, you're going to be flipping back and forth to yesterday's note page. And that one is g of x, until you have it memorized. Okay? So now the second part says to write g of x in just terms of x. So right now this g of x is written in terms of f of x, or based on f of x. So now they're saying let g of x stand on its own. So if my original function, absolute value of, or parent function, absolute value of x was here, it moved over 1, 2, 3, 4, 5, 6 to the left. So if it was going to be a standalone function without building off of f of x, then g of x would be the absolute value of x plus 6, because it went 6 left, the vertex went 6 left from its original position at the origin. Okay, so what is the vertex of f of x? F of x vertex is negative 2, 0. The vertex of g of x is negative 6, 0. What happened between the two vertices? Moved left 1, 2, 3, 4. O, E, F, T. There we go. Tough day today. Alright, so number 2. Parent function, absolute value of x. Okay, they're going to move it up 7. That's what this transformation tells me to do in the back. Shift up 7. Once I have that done, I'm going to take that and I'm going to shift it down 3. So original absolute value of absolute value of x would be down here. Then this f of x, which is the absolute value of x, plus 7 would move up 1, 2, 3, 4, 5, 6, 7. So now here's my vertex. Okay, draw that in. Sorry, I'm stumbling on my words. I've been talking to your guys' parents since 4:30, and it is now 8:30, and I'm still at school making this video, so forgive my stumbles. Alright, so that's f of x. Now I'm going to take f of x and go down 3. So I take the vertex. 1, 2, 3 down. regraph it. So sometimes using our graphing calculators can be helpful or useful as a check, but I can actually draw these faster than I could push all the buttons to enter a absolute value function in the calculator. Okay, and then this would be 1, 2, 3, 4. This would really be g of x equals the absolute value of x plus 4. Vertex is 1, 2, 3, 4, 5, 6, 7, 0, 7. Then 0, 1, 2, 3, 4, 4. And it moved down 3. Whoops, sorry, you can't see that. Okay, remember you can pause and rewind the video as needed. Okay, so let's do one more. So this one is a stretch off of the absolute value of x. So I'll show you how to do that. Then we're going to move that 5 to the left. Okay, this one from the vertex being at the origin, absolute value of x, is going to move right 2, up 4. Then you're going to move that right 3, down 5. Okay, but we're not going to do both of them because I don't want this video to be too long. So let's look at this one. I'm going to go up 1, 2, 1, 1, 2, 1. So I'm making it skinnier because I'm stretching it. So instead of counting up 1, right 1 from the vertex, I counted up 2, right 1, and then up 2, left 1. So that's f of x. And then from here, I'm going to go left 5. 1, 2, 3, 4, 5. Left. 1, 2, 1, 1, 2, 1. Draw that in. That's going to be g of x. So g of x is going to be 2x plus 5. 1, 2, 3, 4, 5 to the left. And the slope was stretched vertically, so the slope became 2. Vertex of f of x. Vertex of g of x. 1, 2, 3, 4, 5. And left 5. Okay? Alright, so using function notation, name the transformation that happened to f of x to produce g of x. So if I went from -7 to -10, and I'm on the inside, it was a change of -3. So that went, whoops, right, because it's inside, right 3. Okay, look at this one. What changed? We got a negative. I got a -3 on the inside, or a -3 on the inside. Plus 9 stayed the same. So it was a reflection over the x-axis. And then it was a shift right 3. Okay? So you're basically just looking to see what was the change, what's different in the equations, and then based on the memorized transformation rules, what happened. Okay? So now, this next section, write an equation involving absolute value representing each graph. Okay, so I would be here. First thing I check is the slope. Slope stayed the same. I went right 1, 2, 3, 4, 5. So this would be g of x equals x minus 5, because it went right 5. This one went down 1, 2, 3, 4. So this would be g of x equals absolute value of x minus 4. Okay, so same concept, going in a different direction. Okay, so again, you have to have those rules memorized. Oh, let's look at 14, because a couple things happened. So I notice that it was reflected, and then it was moved up 1, 2, 3, 4. What? was moved up 1, 2, 3, 4, 5. So that's going to be back here. And then it was moved to the right 1, 2. Okay, reflected, right 2, up 5. Alright, and that's actually it. That's all there is. So you are going to do 17, page 17, that's this page here. Then you're going to do 18, and then you're going to do 19, and if you get stuck, you are going to look back at your notes or rewatch the video and give it your best shot. Now, it says quiz Monday or Tuesday on the board because I was thinking we'd have the quiz Monday and that I'd check in with you and see how everything went, but I don't want to rush it, so if we move it to Tuesday, not a big deal for me at all. So on Monday, we'll just check in with you guys, see how you're feeling, and if we want, we can take it on Tuesday. So, no issues, don't stress out. If we need another day, we take another day. So that's it. Thanks, guys, for being good, and I hope you all have a good weekend, and we will see you on Monday.